anew.
Let's begin.
That's everything we
So we've got 8c, differential equations, and we're just continuing on with our implicit differentiation. So what we have here with question 1, we've got y equals x to the 3, and now we know if we're going to differentiate it, this is what we're going to have. But what we're doing when we're talking about differential equations and solutions to them is we're talking about integrating. So we're going to start with this proposition, and this is going to seem sort of very obvious to begin with, and this is how the exercise begins. We're going to start with this proposition, and what we're going to do is we're going to integrate both sides with regards to x. So what I have here is I have the integral of dy over dx with regards to x, and that's going to equal the integral of 3x squared with regards to x. Now here, all right, we have dx at the bottom and dx at the top, so that can cancel. And you can even think about it like we've got one lot of it. So we've got the integral of 1 with regards to y. That's what's going on the left-hand side, and the same on the right-hand side. Okay, and if we evaluate this, the integral of 1 with regards to y is going to be y, and the integral of 3x squared with regards to x is going to be x to the 3 over 3, which is x to the 3 plus c. And so this is to say, what we found, all right, this is one of the solutions to this differential equation. And in fact, there's an infinite number of solutions to this differential equation. All of them have alternative values of plus c. So we could go plus 1, plus 2, plus 3, plus 4, all the way up to plus infinity, right? So there's an infinite number of solutions, and this is one of the solutions which occurs when c is 0. We've demonstrated that via integration. Very good. Let's move on to the second one. Okay, consider the differential equation here. So we have the differential equation is dy on dx. So the slope, all right, is equal to 2 times the x times the y value. Take 2 times the y value. Okay, so that's a differential equation about the slope. Now I'm not sure what's going on with Vivi here. That's a bit annoying. All right. Show that k equals x squared, take 2x, is a solution. Solution. All right, so we're going to start with y equals k e to the x squared, take 2x. That's what we're going to start with. Okay, now the first thing we're going to do is differentiate this. All right, we're going to differentiate this. And all we have k times e to the power of a function, e to the f of x. And so if we have e to the f of x, the derivative of e to the f of x is f dash of x, e to the f of x. So in this circumstance here, our dy on dx is going to be k out the front, k is just a number. The derivative of our power, that's going to be 2x take 2. And then we have e to the x squared take 2x. Okay, now I'm going to expand all of this. So what we've got is we've got two terms. We're going to have 2kx e to the x squared take 2x, and 2k e to the x squared take 2x. And we will just factorise k. So I shouldn't have distributed that one. That's fine, we'll just factorise it. No, we'll keep it as it was. I'm just looking at what it is exactly that we're doing. Okay, now if we look up here, y equals k e to the minus 2x. So that means we're going to replace k e to the minus 2, x squared take 2x with y. So what we have here then, we have 2x times y, and over here we have 2 lots of y. And so we've shown that if this is the differential equation, then this function is a solution that satisfies the differential equation among a number of other solutions. All right, is that okay? Do we see the y there? All right, I can can write it out even like this. Like here we have k times 2x e to the minus e to the x squared take 2x. Okay, I can rewrite that, and that's k times, well, that whole thing is y. Sorry. Oh my gosh, I'm mixing up the k. 2x, and then I have k e to the x squared take 2x. That whole thing is y. Okay, so we're just performing that substitution there. So that gives us 2xy take 2y. Alright, cool. So that's the first part. Part B is sketch the solution. Now this is what I wanted to bring up Desmos for, but it just says sketch the solution for k is 0, k is plus or minus 1, k is plus or minus 2, and k is plus or minus 3. So all you would be doing is graphing this function, except with k is 0, k is plus and minus 1, k is plus and minus 2, and k is plus and minus 3. And what you'll find is that they're all reflections of each other. So I'll just type in here and then I'll give a quick sketch of what they look like. So let's go with plus or minus 1 to begin with. So we'll have e to the power of x squared take 2x. Okay, and then if we just put a 1 or a minus 1 out front, 2, 3, 4. Okay, so here's what's happening to it. Okay, so it looks something like this, and then as we're increasing the number, it's getting narrower in size, all right? So that's in the positive direction, and then if we have a negative number, well, it's just a reflection in the x-axis. So we'll have this shape here. So that's what the sketches will look like on the graph. I haven't provided room for it because I just wanted to draw out that all of those, okay, all of these are solutions that satisfy this differential equation. All right, so what we're going to draw out in this lesson and future lessons is that this is the slope function that satisfies all of these equations. Okay, we saw over here, this is the slope function that satisfies all of these equations. All right, that one seems very obvious. Okay. Okay, part C. Find the particular solution through x is 1 and y is 1 of e. Okay, we're looking now at a very specific solution. So what we have, if this is the function, let's draw that over, k e x squared take 2x, and the specific solution here passes through x is 1, y is 1 on e. So the first thing we're going to do is find the k value. That's going to be the specific circumstance in which this one occurs. So we're going to put 1 on e where the y is, and we're going to put 1 where the x is. Now we're going to have here 1 take 2, that's minus 1, and that's the same as 1 on e. And so k is 1 for the particular solution. Okay, part D says find the tangent when this occurs. So I sketched up here, when k is 1, when k is 2, k is 3, k is 4. So we're focusing on this particular solution. It's one of the solutions among many, and we're going to find the tangent when x is 1. So tangent occurs. A tangent is the equation of a line, y equals mx plus c. So that means we need two things. First, we need the slope. Okay, so we need the slope function, and then we need the point of contact. Now we've got a point of contact. We're asked to find the tangent here. All right, so we've got the point of contact. We'll list that. 1 and 1 on e, or was it e squared? Oh, we don't have what bin in here, sorry mate. Yeah. Thank you. 1 and 1 on e. And for the slope. Now, we've got differential equations. We're just going to use this one. All right? The slope for all of these equations, even the particular case we're looking at, is 2 times the x value times the y value, take 2 times the y value. So for our slope, we're just going to go 2 times the x value times the y value, take away 2 times the y value. Alright, and so this is 2 on e, take 2 on e. The slope is 0. What does a slope of 0 mean?
It's horizontal.
Horizontal line. So we have a horizontal line here. Alright, so it's going to be the point of the local minimum, the tangent of the local minimum. And so that means our equation is y equals 1 on e. Alright, so let's just take you through how we establish that. We have y equals mx plus c. We have m is 0, so y equals 0 times x plus c. And we have when x is 1, y is 1 on e. So I put 1 on e where the y is. I put 1 where the x is. Alright, so just taking you through how we solve tangents. And when we solve this here, we get c equals 1 on e. So we've established the value of c, we've established the slope is 0, and so we're left with, well, y equals 1 on e. Alright, that's the equation of the horizontal tangent. Does that seem alright? Yep. Cool. Okay, so that's enough to get started on 8C. So do a little bit of it, and then we can do some of your folios. Yeah.